Hi, in this video we'll be continuing the 2021 paper 2 H2 math. And so for question 8, a car manufacturer claims that the front tires on a particular model of car has an average lifespan of 20,000 miles, and the skills manager wishes to test if the lifespan is actually greater than that. So this question tests you probably on hypothesis testing, and the first question already asks, why should he just carry out one tail test? And the reason for that is because he wants to just test greater than, not change, is it different from 20,000. If it was just saying different, then it could be less or greater, so then it'll be two-tailed. But because so you just need the keyword only to test if the lifespan is greater than 20,000, it becomes a one-tailed test. And the null hypothesis, which is denoted by H0, is mu equals to 20,000. So one thing to remember, so the quick way to remember is that the null hypothesis is always an equality, and the alternative will always be an inequality. So the alternative hypothesis will be just H1 mu larger than 20,000, and this mu, it represents the population mean. So what you're asking is whether the mean, which is the average, is 20,000 or not. And the second part just tests you on variable statistic, and basically is whether you are able to calculate x bar and s squared. And so you know x bar is sum of x over n. So but you only have sum of x minus 20. So what you just need to do is sum of x minus 20 over n plus 20. And that will just be equal to this. And because s squared doesn't change under a translation, you can just use the normal one and it'll be the same. Basically, this equals to 1 over n minus 1 squared minus... It's exactly the same. So translation don't affect it. So basically with that, you can surely calculate s squared. Now to do the test at 5% significance level, you just write H0 is this. So you reduce the amount, the 20,000 to 20, makes it easier for calculation sake. Because over here, x is now in 1,000 miles. So with that, by then you might not know the... So you write the standard way, you got H0, you got H1. Then, but because you want to know the test statistic to be normally distributed, but you don't know whether x is normally distributed, but you know that you have a sample of 50. So because it's large, you know by CLT you can estimate x bar by a normal with this as its mean, and this as its variance, but you must divide by 50 lah. Then this is by CLT, so the test statistic will just be a standardized version, so the normal 0, 1. Then you calculate the test statistic, but actually you can just straight away you find the p-value using the data, and with the p-value you see that we do not reject H0 at 5% significance level because the p-value is greater than 0.05. So I hope doing the test is easy for you, and with more practice you should be able to understand it. So now the question is, why is this test actually inappropriate? And in recent years there's more about these questions on asking critical thinking, whether what you're doing is logical or not. And so it'll be inappropriate when it's small because you already assume CLT at the top, which means if it's small then you cannot apply CLT to approximate the lifespan to be a normal distribution. For question 9, it tests you on your linear regression concepts, and basically it first asks you whether a straight line will be a good model. Well, if you see from the scatter diagram, a straight line will not be a good model as it looks to be curving up. So from the scatter diagram, it shows a nonlinear relationship, so a linear model can't be a good one. Now you just need to put this into your GC and draw the best fit, the scatter diagram. With a best fit line for part B. And for part number 2, again, because linear regression is a question that tests you a lot of your GC skills, so you must really brush it up. You can again use the GC to straight away find the linear regression line, which allows you to tell you what is C, D, and also the correlation coefficient. For question 10, now it's like a question that tests you on your concept of the normal distribution, and so you'll get a lot of information and will slowly digest it. So you have a company that makes tools with 4 components. It comes with a seat and 3 legs. So the seat and the legs are bought in bulk, and the mass are all normally distributed. So you got 80% of the seats have 2.1 kg and 15% is less than 1.95. So you just let the mass of the seats be denoted by the random variable x, and the mean of the mass will be mu, standard deviation sigma. So x will follow normal this. So we already know that x being less than 2.1 will be 80%, so it's equal to 0.8. And then you can standardize this with mu and sigma, which means this. So this is your equation 1 and this is your equation 2. Because we know if it's less than 1.95, it's 0.15. So from the GC, we can we use the inverse probability, inverse norm function, and we get the following: 2.1 minus mu over sigma must equals to this 0.8416. And then we get two more equations, which is simultaneous in nature. So we can just use the GC to solve for sigma and mu in that case. Now they say that the masses of the legs is normally distributed as well. So we are supposed to find the expected number of legs with mass more than 1.21 from a randomly chosen batch of 500. So basically, we just need to find the probability that a mass of a leg is more than 1.21. So let the mass of the leg be y and just let y be larger than 1.21. You see that the probability is 0.30853. So the expected number will of course be this probability in a large sample space just times 500. Because the probability of this occurring is this, so you have a very large sample. A proportion of it coming out will be 500 times this chance of occurring. And then you just round off to the nearest whole number. Since it's the number of legs, you can't have a half leg. As for part C, again, it's the same concept. Now we're just finding the probability that is in the total weight is in between 5.6 and 5.7. So we now know that we have the probability of a randomly chosen seat and the distribution of a leg. So the total weight is actually x plus 1 leg, 2 leg, and 3 leg. It's not x plus 3 legs like this. It's 3 legs but like separate random variables, because 3 times y has a different variance from this. And with that, you go calculate the mean, which is just the expectation of this plus this plus this plus this. And for variance, it's just variance of this plus this plus this plus this. So if you have x plus 3y, then the variance is the variance of x plus 9 variance y. But here it's only 3 variance y. So you see the difference in that. You need to be clear that when each leg is different from each other, so you must add 3 different random variables. And then you just calculate the probability using your GC and you should get the answer. Now we are supposed to make circular holes, and the mass of the seat is reduced by 9%. But the mass of the legs is unchanged, so let the new weight be T. So now we know that it reduces by 9%, so it's over here. So you only have 0.91 left, and in which case you calculate again the new mean and variance, and you just use your GC. So it's the same concept, but now you just remember to put a 0.91 for x. As for question 10, a stool is now made of a randomly chosen drill and 3 randomly chosen legs. The legs are paired up with holes at random. Find the probability that 3 legs can be fitted. So basically now you have diameters of holes. So it's like an entirely new probability question which you just tackle using your same methods. So you just let the diameter of the holes be A and the diameter of the legs be B. So we know A is distributed in this manner and B is distributed in this manner. Now to be fitted correctly, we just need B to be less than A and A minus B to be less than 0.8 as given over here. Because the diameter of the hole is more than 0.8, then padding has to be added. And if the diameter of the leg is greater than the hole, so that means B is greater than A, then you have to do something. So you need it to be less than. And then we also need this condition. And we see that we can actually combine the conditions because we can bring the B over here. So it's minus B here and they are the same now. Then we just need to find this. So we just need to find the probability distribution of A minus B. So we just find the new probability distribution of A minus B. And we will get the answer using our GC. So now the probability for 3 legs is this following answer. So you just take 0.567 and you cube it. Now for the last question, we're supposed to, the question starts with another probability question that tests you on balloonist distribution, but it's just a general probability question in general. So each supervisor selects a sample of 10 lights. And how should the fitting be selected? Because you want it to be random, so you just use a random number generator and just choose the lights fitting. This makes the chance of selecting them equal. So now we are given some information and we're supposed to estimate the probability that a light is faulty. So it's basically, we will just use our GC and we can quickly calculate what is the mean number of faulty. And so the probability that a light fitting is faulty is 0.03. Next, we can assuming that the number of faulty findings each day follows a binomial, find the expected number. Well, so we just let f be the faulty and then binomial will be 100, but we know p is 0.03. So we just find f equals to 3, which is 0.22747, and the expected again, same thing. We just take this probability times 150 and you get us 34. Now we are supposed to state some assumptions for us to well model x by a binomial, and so this is the standard answer that we all need to just remember for this exam, A levels, is that the event of each heating element has to be independent and the probability is constant throughout the entire sample. So there's no changing probabilities, and every element must have this is independent of each other. So every probability of selecting something is the same, and the event are all independent of selection. Now x, you know, is distributed by binomial 80 0.02. We're just supposed to find x between 1 to 4 inclusive. Again, use your GC and you should get the answer. Now we're supposed to find a probability that on a randomly 5-day chosen week, more than 3 elements is found faulty at least 2 of the days. So we need to find the probability first that is more than 3 elements is faulty. So the probability that 3 or more elements is faulty is just 1 minus this. We just use GC to find this and you get the answer here. Now the probability at least 2 of the days occur like this is 1 minus 1 day or none. So you just, first one is 1 day, so you just choose 1 times probability this occurred 1 time, and then times 1 minus that to the power 4, minus none of them occurring, so this whole thing to the power 5. And you'll get the answer. And lastly, we're supposed to find the probability that no more than 8 faulty elements are found in total. So in a 5-day chosen week, there are 400 now elements, and the probability is still 0.02. We just want W to be less than or equals to 8, and you can see that it's 0.5925 or 593 3SF. So I hope this question is clear to you. If you have questions, just leave it in the comments down below. If you spotted any kind of mistake, please also inform me and I will answer them again in the comments down below, whether it is right or wrong. So this comes to the end of this paper. I hope you have enjoyed this paper. I'll catch you in the next video and stay tuned. Bye.